This time we're given a cosine function, but the steps are the same for finding period, amplitude, phase shift, start, and end. The only thing that's going to change is when we graph it, we have to do something different with our key points. So when we're looking at this function, the amplitude is still going to be the number out front. So the amplitude of this graph is going to be 1/2. That means that from the midline up to the top and bottom of our graph, we're going to go up and down 1/2. This doesn't have a vertical shift, so our amplitude or our range is going to be -1/2 to +1/2. If we'd done a vertical shift, we would have changed that based on what shift was made. So then the period of the graph is always going to be whatever the period of your function is. So cosine has a period of 2 pi divided by the number that's in front of x. So pi/2. So we're going to do 2 pi divided by pi/2. That's the same thing as 2 pi over 1 times 2 over pi. Those pi's will cancel out, and that just leaves you with 4, which means that the period of this graph, it's going through a full period in 4 units, whatever our units are. So it's going to go through, like, instead of normally sine and cosines are in pi values, this one's going to go through in whole number values. The phase shift. So phase shift is given to us. This one says that we're going to the right. That's the minus sign in there. And then the phase shift is always given by your c over your b value. So c over b for us is 3 pi over pi/2. That's 3 pi times 2 over pi. The pi's cancel and leave you with 6. So our phase shift is going to be moving to the right 6. The minus means right. The number we got was 6. Okay, so then what's going to happen? Well, we can do the 0 and 2 pi equal thing here. We can set the stuff inside our equation equal to 0, set the stuff inside our equation equal to 2 pi, but we can also use the information we've already been given to figure out what these numbers are. So normally cosine starts at 0 and ends at 2 pi. Everything has been shifted to the right 6 now, so our period is actually going to start at 6, and then the period of the graph is 4, so to get through a full wave, we're going to go over 4, which means that it's going to end at 10. All right, let's put all of this together on our graph. So I'm going to just make this work since I don't have a ton of space to go 6 to 10 over here. But 6 to 10 is going to be the full wave of our graph. We know we're going to be going up pi/2 and down, or I'm sorry, up 1/2 and down 1/2. Okay, we're going to go up 1/2 and down to -1/2, and we need to go through a full sine wave in that distance from 6 to 10. So 6, 7, 8, 9, 10. That gives us 5, 6, 7, 8, 9, 10. Act like those are spaced out evenly. So we have our 5 key points spaced out evenly among the integer values from 6 to 10. So cosine. Cosine starts at the top, comes down, goes to the bottom, comes back to the middle, goes back to the top. So at 6, we're starting at the top, we're going down to the middle, we're going down to the bottom, back to the middle, back to the top. So that's our first sine wave. We go curve it down, come back up, we can keep going, come back up, going, come back up. I don't know where it crosses, that's probably not accurate. I didn't pay attention to the y-intercept. You can find a y-intercept if you want to. Plug 0 into your graph, so you'll do cosine of -3 pi, which -3 pi will give you a cosine of -1, and so it'll be -1/2. Oh, so it's not that bad. It's just supposed to be down here, but it's okay, it's close enough. All right, so that's it. We've covered all of it. It was a cosine wave. It's going to go through some more waves than this. In between here, it actually goes through like a full another wave before it gets to 0, but just ignore that. This part of the graph is the important part.